Hello and welcome to Homework 7.02. This is all about solving linear systems with elimination. Just kind of a review. The first thing we ever learned how to do was solve them by graphing, which is where we would find the intersection point of two lines. The next way we learned was substitution, which is where we would plug in one for the other. So if you had something like y equals 2x plus 1, and 2x plus 3y equals 7. You would just take this 2x plus 1 and plug it in for the y. That was the second method. The third way is elimination, which is where we add equations together. So if we look at this first one here, we have x minus 4y equals 16 and negative x plus y equals negative 1. The key to these problems is having opposites. So this one is nice and easy because we already have opposites. We have a positive 1 and a negative 1, which means when we add these equations together, the x's will cancel out because 1 plus negative 1 is 0. So since this one's already set up for us, we're just going to go right to it. These will cancel out. Negative 4 plus 1 is going to be negative 3y. 16 plus negative 1 is going to be 15. A nice short equation here. Divide by negative 3. Divide by negative 3. Y equals negative 5. Now, if we look, there's only one answer that has y as negative 5. So we already know this is the correct answer. But it's not a bad idea to still try to find x just to make sure that you didn't make any mistakes anywhere. So I'm going to take this negative x plus y equals negative 1. I'm going to plug this in. I'm going to get negative x plus a negative 5 is just minus 5, so I'm plugging in this minus 5 here, equals negative 1. Add 5 to both sides. Negative x equals 4. Divide both sides by negative 1, and x equals negative 4. So again, it does match up. You didn't really need to do the x here because there was only one that had a y of negative 5, but it's not a bad idea just to be safe. All right, so let's look at the second one. If the lines whose equations are given to the right were graphed, which of the following would represent their intersection point? So again, we've got our two equations here. We're going to use elimination. Now here we have a bit of a problem because we have 3 and 3, but they're not opposite because they're both positive. All right, what we need to do is turn one of these into a negative 3. So the way we're going to do that is we're going to multiply the entire equation by negative 1. Now it doesn't matter. You could multiply the top equation by negative 1. You could multiply the bottom equation by negative 1. It's not going to matter. You just need one of these two 3's to become negative. So I'm going to do it for the bottom one. So I've got 3x minus y equals negative 20. I'm going to multiply the entire equation by negative 1. Because remember, as long as we do the same thing to both sides, the equation stays in balance. So this is going to give us a negative 3x. A negative times a negative is going to be a positive y. And then again, a negative times a negative is going to be a positive 20. Don't forget to multiply it by this last piece here. That's probably the biggest mistake that I see kids make is they multiply it by the first two and then forget to multiply it by the third. All right, now we take the top equation that we haven't used yet, 3x plus 2y equals 4. I'm going to write that underneath here. And now I'm ready to add these together because with these opposites here, with a negative 3 and a positive 3, they're going to cancel out. And I'll be left with 3y equals 24. I'll divide both sides by 3 and get y equals 8. Now we're kind of in the same situation that we were up above. There's only one that actually has a y of 8, so we know this is the answer, but again, not a bad idea to just plug it in to make sure that you get an x of negative 4. So I'm going to take this 3x plus 2y equals 4, and I'm going to take my 8 here, and I'm going to plug it in. All right, so I get 3x plus 2 times 8 equals 4. 3x plus 16 equals 4. Subtract 16 from both sides. I get 3x equals a negative 12. And then when I divide both sides by 3, I'm going to end up with x equals negative 4. So again, I did get exactly what I expected to get, but better safe than sorry. Check both to make sure that you're getting the right answer. All right. Moving on to the non-multiple choice. Solve each system of equations using elimination. Check your answers in the original system by using store on your calculator. I'm also going to show you a way without using store because it works just as well. Okay, so first things first, what we should notice is that we have opposites. So there's a negative 1, there's a positive 1. So we're good there. We have the opposites that we need, which means we can skip right to adding the equations together. These are going to cancel out. Negative 6 plus negative 2 is going to be negative 8y. Negative 28 plus negative 4 is going to be negative 32. Divide both sides by negative 8. And when you have a negative divided by a negative, we're going to end up with a positive 4. Okay? That gives us half of our solution. We still need to find the x, so we pick one of the two equations. I'm going to go with the bottom one here. I could have picked the top one, but this one had smaller numbers, so I figured why not. The 4 is going to get plugged in here. So I get x minus 2 times 4 equals negative 4, which means x minus 8 equals negative 4. And then if I add 8 to both sides, I'm going to end up with x equals 4. So again, if we were to actually graph these lines, we'd be seeing that they intersected at the point 4, 4. Okay? Now, how do we check these? All right. There's two ways to do this. If you want to use the store function, you can. You would say 4, and then you'd hit the stow key. So 4 stow. It's going to make a little arrow, and then your x key. We could do the same thing for y. So 4 stow, and then to get to y, it's alpha 1, and that's going to give us 4 arrow y. And what this does is, this is just the calculator is going to plug the numbers in for us, so that when we type in the first equation, negative x minus 6, and then again, alpha 1 to get the y, and we hit enter, we're going to see that it's negative 28, just like it should have been. Down here, if we type in x minus 2, again, alpha 1, y, hopefully we're going to get negative 4, and we do. So both of those check out. You can also just plug the numbers in by hand. You don't have to use the calculator to plug them in. You could just say, all right, the first one's negative x, so that's going to be negative, and then I'm plugging in my 4, minus 6, and then I'm plugging in my y, and you'll get the same negative 28. And you can do the same thing down below, plugging in the 4 for the x, minus 2, and then plugging in the 4 for the y. You're going to notice that I'm using parentheses every time I plug it in. That's just a way to make sure you're getting the negative signs right and all the calculations are working out just the way they need to be. It's just safer to do it with parentheses. You don't always need them, but it's just safer. And you're going to see that they check out the same either way. So both ways are perfectly acceptable when checking these. All right, let's take it over to the back. Solve each system of equations using elimination. Check your answers, so pretty much the same directions. But what you're seeing here is, again, we do not have opposites. So we would like to make opposites. Usually when I'm picking which letter I want to get rid of, if there's one letter that already has a negative sign, I go with that one. So if we look, the x's are both positive, positive 4, positive 5. Whereas the y's, I have a negative and I have a positive, so Generally, the y's are a little easier because I've already got that negative sign that I'm going to need. All right, when you're canceling things out, you're always going to need one to be negative, one to be positive. So if I've already got it, let's take advantage of that. So here's a negative 3. The opposite of a negative 3 is a positive 3, which means this y right here is going to need to be multiplied by 3. But I don't get to just multiply one thing by 3. I have to multiply the entire equation by 3, which means this 3 needs to get multiplied by the 5, it needs to get multiplied by the y, and it needs to get multiplied by the 9. I have to do the same thing to both sides. When I do that, I'm going to get 15x plus 3y equals 27. Underneath that, I'm just going to write my top equation. So 4x minus 3y equals 11. And now you'll see I have my opposites. One is positive, one is negative, and the numbers are the same. So I'm ready to add these together. 15 plus 4 is 19x. The positive 3 and the negative 3 are going to cancel out. 27 plus 11 is 38. Okay. Now divide both sides by 19, and I get x equals 2. All right, so that's step 1. Step 2 is to find my y. I need to have both letters. So again, you pick either one of these. I'm going to go with this one just because it doesn't have subtraction, which means there's no negative signs to worry about. So let's see, 5x plus y equals 9. All right, this 2 is going to get plugged in for the x. So 5 times 2 plus y equals 9. 10 plus y equals 9. Subtract 10 from both sides, and you're going to end up with y equals negative 1. So again, if we had two lines, these would be intersecting at the point 2, comma, negative 1. All right, that's the intersection point of these two equations. If we wanted to check that, you can either use stow, where you're going 2 stow x and negative 1 stow y, and then type them in. So 4x minus 3y, hopefully that's going to give me 11, and it does. 5x plus y, hopefully that's going to give me 9, and it does. Or you can just do them kind of by hand and say, all right, 4 parentheses 2 minus 3 parentheses negative 1. Yep, that gave me 11. And then the same thing down below. 5 parentheses 2 plus negative 1 for my y. And that gave me 9, and they're both checking out. You just have to think about this as kind of like the old school, middle school checking that you used to do, where you just plugged in the numbers and made sure both sides were equal. That's basically what we're doing. We're just plugging in the numbers and making sure both sides are equal, just like you had to do kind of back in middle school. All right? So I hope this was helpful, and have a good day.